we'll see a trick to find the adjoint of a matrix is determinant, and hence we can find the inverse of matrix. So this trick is basically to find the inverse of matrix. Okay, but for finding inverse we should know the quick method to find the adjoint. So first we'll see the trick, then we'll see the proof, how to find why we are getting this trick. Okay, so let's start with example. So let's say a matrix A is 1 2 3 2 3 2 3 3 4. This is some matrix A. Now see the approach. First start with the second column and second row. So this is the 3. So first we start with the second column. Okay, second column is this, and start with 3. So see how I am writing 3. This is the second column, second row. Then in the same second column 3. Then move to 2, and then we move to again 3. So this is how the pattern is. 3 3 2 and again 3. Okay, so with 3 3 2 circular form. Start with 3, the second column, second row, then 3 and 2. So this is basically we have considered here the second column. Now we'll consider third column in the same manner. So second column means this one, but start from the second row. 2 4 3. So 2 4 3 again 2. Why I wrote again 2? 2 4 2 4 3 and then 2. So 2 4 3 2. This is circular form. Okay. Then next we'll consider the first column. So first column means 1 2 3, but start from the second row. 2 3 1 2. So 2 3 1 2. Fine. And now what I will do, I will just repeat this second column, these elements again here. So I am just repeating this again here. So that means 3 3 2 3. That's all. Once we wrote this, now quickly we can find the adjoint. So if I have to find the adjoint of a matrix, see, adjoint of a matrix A is very quick. See how I'm writing. We'll just do this one multiplication. So this cross multiply 3 4 and 3 2. So what I am doing, 3 4 are 12 minus 6. Okay, 12 minus 6. So here understand, basically here I am getting 12 minus 6. Similarly here also 3 3 are 9, 3 are 9 minus 8. So again here 9 minus 8. So I am doing here same here also 9 minus 8. Similarly here 4 minus 2 2 are 4 minus 9. This is 2 2 are 4 minus 9. Okay. Then we repeat again with this one. 2 3 are 6 minus 8. So 3 2 are 6 minus 8. And same here, 4 1 are 4 minus 9. So this is 4 minus 9. And this is 3 2 are 6 minus 2. So this is 6 minus 2. And the same here again, this 2 3 are 6 minus 9. That is 6 minus 9. And 3 2 are 6 minus 3. 6 minus 3. And 3 1 are 3 minus 4. 3 minus 4. So this is our, if we simplify it more, so our adjoint will be just 12 minus 6 is 6, 9 minus 8 is 1, 4 minus 5 minus 5, and 6 minus 8 is minus 2, 4 minus 9 minus 5, 6 minus 2 4, and minus 3, 6 minus 3 is 3, and 3 minus 4 minus 1. So this is the adjoint of a matrix. Okay, so this quickly we can find the adjoint of matrix. This is matrix A, this is the adjoint of matrix. And once we know the adjoint of matrix, we can directly find the determinant. So determinant also easy. So see, determinant, if I want to find determinant of A, what I will do, I will take any of things, but here I can take the row first with the column 1. We multiply row 1 and column 1. So here basically we multiply row 1 of A, matrix A into column 1 of matrix adjoint A. Okay, so determine row 1 means here 1 here and here 6 here. So 1 into 6 plus again 2 here and minus 2 here. So here 2 into minus 2 and again 3 here and minus 3 here. So this is 3 here and minus 3. So that becomes 6 minus 4 minus 9. That means it is minus 7. So same can also be, see, if you want to find determinant, same can also be obtained if we multiply the second row with the second column. So same can be also obtained. So alternately we can also find that determinant A, can also find that row 2 second row of A multiplied by column second of adjoint of matrix A. Okay, so row second means 2 multiplied with 1, so that is 2 into 1 plus 3 multiplied with minus 5, so 3 into minus 5, then 2 multiplied with 3, 2 multiplied 3, so that becomes 2 minus 15 plus 6, that is again 7. Okay. Similarly, we can also have the same determinant if we multiply the third row with the third column. Okay, so once we know the determinant, adjoint, now we can find the inverse. So inverse is nothing but the adjoint of A divided by the determinant of A. So we can directly, using this and this, we can directly write the value is divided minus 7. So I will write here 7 and multiply minus inside, so it become minus 6 minus 1 5 2 5 minus 4 3 minus 3 1 for a practice. So let's, the matrix is like this, 1 2 minus 2 minus 1 3 0 0 minus 2 1. Okay, for finding the adjoint, so what I will do, 3 minus 2 2 3. Understand the way I am writing? 3 start from second column and second row, so 3 minus 2 2, then 0 minus 0 1 minus 2 0, so that becomes 0 1 minus 2 0, then first column starting with the second row, so minus 1 0 1 minus 1, start with the second row, so second column 3 minus 2 2 3 3 minus 2 2 3, then the third column 0 1 minus 2 0 0 1 minus 2 0, then first column minus 1 0 1 minus 1 minus 1 0 1 minus 1, and next what we'll do, we'll put the same here, replace here, that becomes 3 minus 2 2 3. Now we can directly write the adjoint of a matrix. So I think now, so directly we can say this is 3 minus 0. 3 minus 0 is here directly 3. Similarly, minus 2, that minus 2 is 4 minus 2. 4 minus 2 is 2 here, and this is 2 0 and minus 6. So 0 minus 6, 0 minus of minus 6, that becomes 6. Then this 0 minus 1. So 0 minus minus 1, that becomes 1. Basically this is what? This is 0 minus of minus 1. Okay, this is 0 minus minus 1. So that becomes 1. Similarly, 1 minus 0, that becomes 1. This is minus 2 into minus 2 is 2 minus 0, that becomes 2. And this is minus 1 into minus 2 is 2, and 3 minus 3 zeros are 0. So that means this is 2. And this is 0 into 2 is 0, and minus 2 into 1 is minus 2. So 0 minus of minus 2, that becomes 2, and similarly here 3 1 ja 3 and 2 minus 2 is 2 into minus 1 is minus 2. So this is 3 minus of minus 2, that becomes 5. So this is the adjoint of matrix. Now the determinant of matrix is directly, you can use any of the column. Let's say start with the first row and the first column. So first row, first column, so that means 1 multiplied by 3, that becomes 3, plus 2 multiplied by 1, so 2 multiply 1, 2 1 2, 2, plus then minus 2 multiply with the 2, so minus 2 into 2 is minus 4, so that becomes minus 4. So that is 5 1, so this is 1. So now A inverse is directly adjoint of A divided by matrix A. So we can directly write this is nothing but, because this determinant is already 1, so this is the same adjoint. So 3 2 6 1 1 2 2 2 5, this is the answer. Okay, so see how quickly we got the answer, writing one matrix, this is 2, and the third we just writing adjoint. Let's take the proof. So why we are getting this, what is the logic of getting this form as the inverse? Okay, so let's see the proof. So if anyone interested, they can go for a proof. Otherwise the trick is completed here. For a proof, if you want, you can look the proof. So let's say I have a proof. Okay, so let us take any matrix. Let any matrix A is like this. Let's say this is A1, A2, A3, B1, B2, B3, C1, C2, C3. This is matrix A. And in a vector form, I am writing like this: matrix A, matrix B, matrix C. So basically, matrix A is nothing but A1, A2, A3, and matrix. I am sorry. The vector A is, so basically what I am writing, this is a matrix A1, A2, A3, B1, B2, B3, C1, C2, C3. This first row can be written as a vector form. So this is vector A. Second row can be written as a vector form, vector B. Third row can be written as a vector form, that is a vector C. So basically vector A is A1, A2, A3. Vector B is B1, B2, B3, and vector C is C1, C2, C3. So this is vector A. Now I am assuming a inverse matrix. Inverse, let us assume a inverse matrix is like this. So I am writing in this manner. So D1, D2, D3, E1, E2, E3, F1, F2, F3. So you will shortly understand why I am writing like this. So this I am writing in a, so this is just a column vector. I am just writing as a row vectors like this: vector D, vector E, vector F. Okay, so that means vector D is nothing but D1, D2, D3. Vector E is E1, E2, E3, and vector F is F1, F2, F3. And you will shortly know why I wrote like this in a, this is in a column form and this is a vector form. Because the obvious reason is, because we know that for inverse matrix A inverse is equal to identity matrix. This is a property which is held by, if the matrix A is multiplied with the inverse, we'll get the identity matrix. And this matrix hold, this multiplication hold, if the vector A is written like this: A, B, C, and A inverse written like D, E, F. So this multiplication hold only if the 3 cross 1. So this is a 3 cross 1 matrix, and obviously A inverse should be a 1 cross 3 matrix. Okay, so this multiplication hold only if the number of columns of matrix A should be number of row of A inverse. So this is how the multiplication is possible. Otherwise multiplication not possible. So we can't write A as a in a column for, or and A inverse also in column for, because if both in the column form, the matrix multiplication is not valid. Okay, fine. So once you understood this part, let's write in this way. So A, what is A matrix? A matrix is A, B, C. And what is A inverse matrix? We have assumed this is D, E, F. And that is same as the I. I matrix means identity matrix. Okay. Now if I multiply, obviously if you multiply this part, we'll get something like this. A dot D, this is first row and first column. Then again here A dot E, first row second column. Then A dot F, this is how we multiply A dot D, A dot E, A dot F. That will give the first column of first row of the multiplication of matrix A and A inverse. Similarly here, similarly B dot D, B dot E, B dot F, C dot D, C dot E, and C dot F. This is same as 1 0 0 0 1 0 0 0 1. Okay. Now if we compare them both the matrices, clearly we see that the off diagonals are 0. So we have this form A dot D, not A dot D, sorry, I'm talking about the off diagonal matrix. Off diagonal is 0. Okay, this off diagonal is 0. That means A dot E is equal to, let's say, A dot F is equal to C dot D is equal to B dot D, and so these all are 0. So what does it mean? Let's go one by one. So let's say B dot D is 0. So if I say, let's say I am talking about this matrix, this element of the matrix, B dot D is 0. So B dot D is 0. So B dot D is 0, and also let's take the C dot D is also 0. So understand, B dot D is 0 and C dot D is 0. So B dot 0 and C dot D is 0. So since this and these are 0, it clearly means that if the dot product is 0, that means it means that B vector is perpendicular to D. Similarly, this also means C is perpendicular to D. So clearly a vector D is perpendicular to B. Similarly, a vector D is also perpendicular to C. So what does it mean? It means that if the vector B is perpendicular to D as well as perpendicular to C, that means vector D is parallel to B cross C. Okay, I think this is a vector concept. You know that D is perpendicular to B and also D is perpendicular to C. So that means clearly D is parallel to B cross C. If D is written like this, suppose this is vector B and vector D is perpendicular to B, and also vector D is perpendicular to C. That clearly means the B cross C will be parallel to D. Okay, so that so we can say that D is parallel to B cross C. It may be any direction. So we can write that the D is something constant K B cross C. So let's compare its unit vector. So since they have same direction, so direction is same. Okay, so let's write in the unit vector form, unit vector, because the magnitude remains same, unit vector form. So I can write like this: vector D upon D, that is the magnitude of this, is same as the magnitude of this. So magnitude is same, and since they are parallel, so I can say plus or minus, because we don't know. Parallel means it may be a same direction, or so it may be B cross C. If it is in this form, so B cross C will be like this. Or if C is somewhere here, then B cross C will be like this. Okay, so but ultimately this vector D is parallel to B cross C, either it may be in the same direction or in opposite direction. So we should know that this magnitude is same, unit vector, and this also unit vector. Magnitude is same and direction is also either same direction or opposite direction. That means they are parallel. Okay, this is one concept. This is one thing we should in mind. Let's say this is equation 1. And second, if we look at the other form means A dot D. So A dot D is 1. No? We compare this diagonal elements. So A dot D is 1, B dot E is 1, and C dot F is 1. So let's talk about A dot D. So clearly A dot D is equals to 1. What does it mean? It means that if the angle between, suppose, A and D, so I can write A D cos theta is equal to 1. Obviously, suppose this is vector A and this is, let's say, vector D. Angle between them is theta. So what does the magnitude of D? Magnitude of D is 1 upon vector A cos theta, and theta is angle between A and vector A and D. Let's say I write A dot B cross C. Now we understand why I'm writing A dot, because we already have B cross C. Okay, we have a magnitude of D, we have magnitude of D, and we don't know magnitude of B cross C, but we know that A dot B cross C is, we can write like this: magnitude of A, magnitude of B cross C, and cos theta. Now you understand why this theta is same, because suppose this is vector A and this is theta is also the B cross C. Why I am saying B cross C? Because the direction of D and B cross C is same. Agree? Direction of a vector D and B cross C same. So using A dot D, we could find out the magnitude of vector D, and using the scalar triple product, we could find the magnitude B cross C. So again here, I can write the magnitude of B cross C is B cross C is equal to triple product A, scalar triple product, upon A cos theta. Fine. So now we know the magnitude of D, we know the magnitude of B cross C. Now using this second and third, substitute, because ultimately what is our aim? Our aim is to find the D, because unknowns are what? So vector ABC is known, we don't know the A inverse. A inverse means DEF. We need to find the vector D. So that's what I am doing, is to find the vector D. What is vector D? If we look at from this equation, vector D upon magnitude of vector D is equal to B cross C upon B cross. So let's take one sign, plus or minus. So D is magnitude of D, B cross C upon B cross C magnitude. Now, but if we take the plus here, angle between B and C is plus, then we take plus also here. But if take is minus here, this is also minus here. So minus minus become plus. So ultimately it will be plus here, always plus. This is always plus. Okay. So vector D, let's substitute the value of magnitude of D. Magnitude of D is 1 upon mod A cos theta, and let's say, so we have magnitude of D 1 A cos theta, and let's say magnitude of B cross C. So B cross C vector divided by B cross C. Now observe what is happening here. So if you look at from this equation, A dot B cross C is magnitude of A, magnitude of B cos theta, and this is nothing but B cross C upon magnitude of A, magnitude of B cross C cos theta. So vector D is nothing but B cross C upon A dot B cross C, scalar triple product. So now we could find the vector D. We know the vector B, we know the vector C, the cross product divided by the vector A we know, vector B we know, vector C we know. So this is how we can get the vector D, that is D1, D2, D3. So we should find the cross product of B and C and the scalar triple product of A, B, C. And obviously we know that vector A, vector B, vector C is known, and vector D, vector E, vector F is unknown. So here using this formulation we could find the vector D. Similarly we can find the same logic, we can find the vector E. So vector E is again C cross A upon B dot C cross A. Okay, and similarly vector F, A cross B upon C dot A cross B. Okay, so this is how we can find the vector E, vector F and vector C. Okay. Also know that A dot B cross C is nothing but we can write in box form A, B, C. Similarly, B dot C cross A is also in a box form, and since they are in cyclic order, we know the cyclic order remains same. This is A, B, C. Since they are in cyclic order, so same. So B, C, A. So this is also A, B, C, and C dot A cross B. This again a cyclic order A, B, C. That's why this is A, B, C. So that means vector D can be written as B cross C upon box of A, B, C. Vector E can be written as C cross A divided by box of A, B, C. And vector F can also be written as A cross B divided by box of A, B, C. So that means what is our A? A was A, B, C. So what is our A inverse? A inverse was D, E, F. And what is D, E, F? B cross C, C cross A, and A cross B. This and divided by 1 upon A, B, C. Okay, scalar triple product. This is the one of the formulation in terms of a vector. And if we just look at in general form, so see how I am writing. Let's say vector A is A1, A2, A3, B1, B2, B3, C1, C2, C3. This is vector A. Now what is B cross C? Let's write like this: I, J, K. B is B1, B2, B3, C1, C2, C3. This is I times B2, C3 minus C2, B3. J is B1, C3 minus C1, B3 plus K times B1, C2 minus C1, B2. This is the B cross C. What is A dot B cross C? Scalar triple product. You know that this is nothing but the determinant of this A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay, so this is the vector. This is the matrix A. This is B cross C. This is A cross B cross C. So if we want to find the inverse, so inverse. So let's talk about this one. So we know that D1, D2, D3. Recall that this was the vector D. So for A inverse, vector D is B cross C upon A dot B cross C. So this is nothing but the determinant of A. Understand? This is the determinant of A. Okay. So this is B cross C upon determinant of A. I am talking about just a D. It means if you look at the this, so clearly D1 is B2 C3 minus C2 B3. D2 is B1 C3 minus C1 B3. In fact, this is minus, so this is minus here, and D3 is this. So B1 C2 minus C1 B2. So clearly, if I have to say A inverse 1 upon determinant of A, this one we have already discussed, determinant of A, B, C, and B cross C, C cross A cross B. So B cross C is D. So D means here we get D1, D2, D3. Here similarly we get E1, E2, E3, F1, F2, F3. Okay. So this is what we got. The see the way I wrote the general form like this, no? Just one part. So this is, so what was the formula? The formula says that write in this form B2 C2 A2, okay, B2 A2 C, and then again repeat this B2. Then the third column is B3 C3 A3 and then B3, and the first column is B1 C1 A1 and again B1, and then we repeat this part here, so that becomes B2 C2 A2 B2. Then what is adjoint of A? Now clearly if I have tried the adjoint of A, I am just writing the first column of adjoint type. What is this part? So this part, let's write like this. This is what? B2 C3 minus C2 minus B3 C2. This. Then let's talk about the this one here. That means B3 C1 minus B1 C3. Then talk about the this one. That means B1 C2 minus B2 C1. This. So I am just looking at the first column, and you see this is nothing but D1. So this is the D1. What is D1? B2 C3 minus C2 B3. This is this part. Okay. Then second column is minus B1 C3. So this is just convert into C1 B3 minus B1 C3. So this is the second row. So this is B3 C1 minus B1 C3. So B3 C1 minus B1 C3. Okay. Then the third is B1 C2 minus C1 B2. So B1 C2 minus B2 C1. So see, this is how we get the first column. Similarly, second column and third column we can get. Okay. So I am just calculated the first column. We can get the similarly second column, third column. Second column, clearly we observe that this is C cross A. Your C cross A. So we observe here that this first column, that is B cross A, and this part we see that this is nothing but C cross A, and this part is A cross B. So this is B cross A, this is B cross A, this is C cross A, and this is A cross B, and this is what we get. If you recall this one, B cross C. So this is what B cross C, B cross C, C cross A, and A cross B, and this is what, this is B cross C using this one. Similarly, C cross A we get the second column, and A cross B get the third column. So this is how the formula has been derived using the vector approach. And I think if you find that the proof is little bit lengthy, but no worry, you just know the approach. But if you are curious why we are getting that particular value and what is the reason of getting that formula, then you can look at the proof form. Okay, so I'm ending.